Good Wednesday evening. Well, we need to have our foldable out, and last night we talked about graphs, how to the introduction to linear relationships with you can graph it, and now we're going to look at from a table. So we're going to go ahead and jump right in. So let's flip that table flap up. And we're going to write some notes. So number one, what you need to know about linear relationships from a table is that every input has only one one output. So here's what I mean by this. Your x values cannot repeat. Okay? And the second thing that we need to know about a table is that there is a constant change among the y values and a constant change among the x values. Okay? So, let's look at our table. So it says, indicate whether or not each relationship is linear. The first is done for you. Well, the first is not done for you this time. I'm doing it with you. So, sorry, the first is not done for you. Okay, so let's see. Looking at our notes from today, every input has to have one output. This is input. Let's label that. Your x values are your input, and your y values are the output. You will hear those names interchangeably. X is input, y's are outputs. Okay? And your x values cannot repeat. So, let's look at our x values. Do you see any repeat numbers? Yes. 2 is repeating. So now, is this linear? No, it is not linear. So, let's jump to the second one. Do you see any repeating numbers? No, no repeating x values. We don't care about the y's. We don't have to look at those, just the x. So let's look at number 2 on our notes. There is a constant change among the y values, a constant change among the x values. So let's go back to our chain, see if there's plus 1, plus 1, plus 1, okay? So there's a constant change there, plus 2, plus 2, plus 2. Constant change there. So it is linear, yes. Okay, let's look at this. Plus 1, plus 1, plus 1, plus 1, plus 3, plus 5. Is it constant change? Well, it is a pattern, but they're not the same pattern. So, remember, it needs to be the same pattern, so we're going to say not linear there. Not linear. Okay? Because they're not increasing by the same number in the y values. So let's look at let's look at the last one. Are there any repeating x's? That's our first test. No. So let's look at plus 2, plus 2, plus 2. Okay? And over here we have 2, 2, 2. Linear? Yes. Linear. Okay? So let's go ahead and jump into equation because I'm not going to be here in class tomorrow, and I want you guys to have these notes already. So that's going to take away one video that you won't have to watch tomorrow. So now this will be our last video of the week. Okay, so equation. Let's look at equations. We're going to go ahead and do those. So I'm going to flip over my table, notes, and we're going to look at equations. Our first rule with equation is there can be no exponents. There are no exponents. So, for example, x to the second power, not a function. Okay? Alright, so and the second rule is very short. There has to be a y. There must be a y in equation. In the equation. There has to be a y. So let's look at our examples. Indicate whether or not each relationship is linear. Okay? So let's look at our rules. No exponents. Do you see any exponents here? Yep. So that's not linear. Are there exponents? No exponents. Is there a y? Yes. There is a y. I see it. It says y equals. So it's going to be linear. And lastly, next. Is there an exponent? No. Is there a y? Yes. Even though there's no x, it's still linear because our rules don't say anything about x's. And let's look at the last one. Are there exponents? No exponents. Is there a y? No y. So it is not linear. Okay? I want us to write down a few notes underneath this. Well, actually, I really want, instead of doing that, let's go back to our Unit 4 map. Remember this? So, we talked about, I told you we would be going through this map. We're going to start with things that are proportional first. We've already done, anytime you see a k, k equals constant. So write that down, maybe, and make a note for yourself. K in math means constant. So we're always looking for constant things, constant rates of change when we're talking about proportional. So all of this over here is going to have a K on the proportional side because they're all constant if they're proportional. So let's look here. We've already looked at the rate of change in a table. We've already looked at the slope of a graph if it's linear. We've looked at some word problems last unit, and we now know that k equals constant. Okay, so we've done all these things here. So let's go back up to the top here. Direct variation. So there's two equations that you're going to learn in this unit, and one is for things that are proportional, and one is for things that are not proportional. If they're proportional, which is what we're doing today, your equation is y equals k, which is our constant, times our x value. Y equals k times our x value. So I'm going to go back here in the equation part of our notes, and on the bottom, we're just going to make a note. We call this direct variation, and that's just fancy math speak for let's make an equation out of what we see. So direct variation, when you hear that, it's referring to that proportional equation of y equals kx. Okay? Y equals k, which is the constant rate, times x. So let's write that down. K equals constant rate. Y equals your y value. X equals x value. Okay? And that's all we need to know, and you'll be good for tomorrow's work in class, and also no video for Thursday night. This is your last video. So have a good night, and I will see you Friday. Be good tomorrow. Bye, guys.